Okay, so let's talk about the semester exams FRQs. So the first question is an implicit differentiation problem. We were given an equation and asked to find the derivative, and we're given what the derivative is. So first, to change it over to the Newton notation. And then I'm going to take the derivative. So this first thing involves the chain rule. And then the second one involves the product rule. And then just like the normal power rule. And then the constant multiple rule. And then the derivative of a constant is 0. So then I need to I'm going to switch it back to the Leibniz notation before I do anything else and simplify some stuff. So this would be 6y squared dy dx plus 12xy plus 6x squared dy dx minus 24x plus 6 dy dx equals 0. So I'm going to get all the terms that have dy dx by themselves and move everything else to the other side and factor out the dy dx. Divide both sides by what's there next to the dy dx. And then both the top and the bottom of this thing, that's an arrow, have a common factor. So I'm going to pull out the 6 on top and bottom. And then cancel it. And it looks like the thing that we started with. So that's part A. Part B says to write the equation of each horizontal tangent line to the curve. So horizontal means the slope is equal to 0. And that only happens when the numerator is equal to 0. Now, when I'm solving this, I need to keep in mind that I can't divide by a variable because I might be losing a solution if I do that. So I have to factor out 2x, and that gives me two conditions. 2x equals 0, or basically where x equals 0, and then when y equals 2. Now, you can't stop there because that's where the derivative is equal to 0, but you don't know if those points are actually on the graph. It's possible for the derivative to give you a number where that number can't even occur on the graph. So what I'm going to do is take each of these numbers, x equals 0, y equals 2, and I'm going to plug them into the curve itself to make sure I know the point on the graph which they occur. So if I start with the x equals 0, that would give me 2y cubed plus 6y equals 1. And this is something that, because you're using a calculator, you should just go ahead and use your calculator to solve. And when you do, you get y equals 0.165. So horizontal tangent line is going to be y equals number, so this is one of them. So now I need to take y equals 2 and plug that into the original function as well. So when I do that, I get 2 times 8, which is 16. And then I get 6 times 4 times y. Oops, I plug in y equals 2. 6 times 2 times x squared, so 12x squared, minus 12x squared, plus 6 times 2, which is 12, equals 1. So this tells me basically that 28 equals 1. That never happens. So that means basically y equals 2 is not on the graph. So the only equation of a horizontal tangent line I have is this y equals 0.165. Now, part C. Part C, we've got the line that has this with the origin with a slope of -1. which of course is the line y equals negative x. And it's tangent to the curve at point P. So that means it actually touches the curve and shares the slope there. So since it's tangent to this graph and it shares a point there, that means they intersect, right? So that means if I do a system of equations with those two, y equals negative x, the line, and the original curve, I should be able to solve for the x or the y value. So I'm going to replace all the, let's say, the x's. I want to replace all the y's with negative x. So if I do that in the original problem, that's 2 times negative x cubed. So that's negative 2x cubed. And then 6 times x squared times negative x. And then minus 12x squared plus 6 times negative x equals 1. And I would combine those like terms that I have. And then I would use my calculator to solve that. And I get negative 1/2. Although really, I think my calculator gives me like negative 0.499999. That rounds to negative 1/2. So I'll just go with negative 1/2. And since x is negative 1/2, y is the opposite sign, so the coordinates are negative 1/2, positive 1/2. And that's question 1. Here's question 2. You're given a derivative of a function and an initial value, and you're asking questions. So, part A, find all the values for which a graph of h has a horizontal tangent. So, horizontal tangents would be where the derivative equals 0. And that would happen when x squared minus 2 equals 0, which happens at 2 places, positive square root 2 and negative square root 2. And we're asked to do a local min or local max. Now, that means we're going to do a sine line. The problem with this is they asked you to find the horizontal tangents, but they didn't ask you to find all the critical points, which you need when you're doing a sine line. You need not only the places where the derivative equals 0, which are these, but the places where the derivative is undefined. And that happens when x is 0. So when I put my things on the sine line, I need to include that 0 because that could make a difference in my sine analysis. So essentially, when I go to plug in numbers and do this sort of like figure out what's going on, when I plug in negative like 4, which is less than negative root 2, I get a negative number. And I plug in, say, negative 1, I'm going to get a positive number. When I plug in 1, I'm going to get a negative number. And when I plug in something bigger than root 2, I'm going to get positive. So basically, this graph does that. So both negative root 2 and root 2 are relative mins. Because the derivative is negative to the left and positive to the right. Part B. Over what intervals is the graph concave up? So concavity is based on the second derivative, so I need to find that first. So low, d high, minus high, d low, over low. And I'm going to simplify that. So it's 2x squared minus x squared minus negative 2. So that would be x squared plus 2 all over x squared. And then I need to find the critical points for that. So the top can't equal 0. So that means the second derivative here cannot equal 0. But the bottom means that it could be undefined. So h prime can't equal 0, but it's undefined at x equals 0. So when I make my sine line, I need to put 0 on there. So if I plug 0 into this thing, it's going to be positive. That's 0. Plug in a negative number, and plug in a positive number is also going to be positive. So that means basically it's concave up everywhere except 0, where the graph itself isn't differentiable. So you could rewrite that several ways. I'm going to write it just in the interval notation. Negative infinity to 0, 0 to infinity. Not including any of those things because the second derivative is greater than 0. Part C. Write an equation for the line tangent to the graph. So we need a slope and a point. You're told in the problem that h of 4 is -3, so the point is 4, -3. And then we know h prime, so if we find h prime of 4, that would be 16 minus 2 all over 4, so that's 7 halves. And so my line can be in any form, but I always use point slope, it's just the easiest, is that. And then part D. Part D, they give you h of 3 is 5, and you want to know what j is edge inverse, and write the equation of a tangent line. So I would need to know, first of all, j of 5. Well, since j is the inverse of h, it's going to take 5 and send it to 3, because h of 3 is 5. So that means the point 5, 3 is on the line, is the point of tangency. And then to find the slope, I need the derivative. It's going to be 1 over j prime. Oh, sorry. And since that's true, it's the derivative, that's the inverse of h. So it's going to be 1 over h prime of h inverse of 5. H inverse of 5 was 3. And then h prime of 3, you plug 3 in up here, and you get 9 minus 2 over 3, which is 7/3. And so the equation of my line is that. So here, you're given x of p, which is a position of a particle p, and you're given v of q, which is a velocity of a different particle q. All right. So when I go to do this problem, part A, when is particle p moving to the left? So it's moving to the left when the velocity of p is less than 0, and the velocity of p is the derivative of the position. So I need to find the velocity. So the derivative of the ln of t squared minus 2t plus 10 will require chain rule. It'd be 1 over the thing that's on the inside times the derivative of what's inside. So I need to know where that's equal to 0, where it's undefined. So if you tried to take the bottom and tried to think about it, the quadratic formula, b squared minus 4ac, the thing that's under the square root, would be negative. So it's not going to have any real answers. So the only thing I have to worry about is the whole derivative equaling 0, and that happens when t is 1. So I'm going to draw my sine line. They did tell us we were talking about the interval from 0 to 8, so I'm going to cap my sine line with those numbers, and then put my critical point there. And when I plug in the numbers that I am testing, basically, I'm going to get a negative here and positive here. So it's moving to the left when t is between 0 and 1. Now you would include 0 here. I didn't count it off if you didn't, because when you plug in 0 into the velocity, you actually do get a negative number. And that's true because the velocity of p is less than 0. Part B. Find all times during which the two particles travel in the same direction. Well, we already know which direction particle P is traveling. Now we need to know the direction of particle Q. Now, this is where you have to be careful. They already gave us the velocity of Q, so we don't have to take the derivative. We already have what we need. So if I were to take that to make a sine line for it, there's no place it could be undefined, so I'm going to see where it equals 0, and that happens if you were to factor it at 3 and at 5. So I'm going to make my sine line. I didn't label my first one. Let me go back and make that change. So now I can label this one. This one's v of q. Again, we're capping off at 0 and 8, and the numbers that I got here are 3 and 5. So if I go and test the numbers that I have positives here, and then between 3 and 5, I'm going to have negative. and then 5 and 8 is going to be positive. So it's traveling the same direction anytime these things have the same sign. So if you look at the two sign lines and contain them, those times would be between 1 and 3, and then again between 5 and 8. And that's because V of P and V of Q have the same sign. Part C. Find the acceleration of particle Q at time 2, and then talk about whether the speed is increasing, decreasing, or neither. So acceleration is the derivative of velocity. So the derivative of this velocity would be 2t minus 8. And if I find the acceleration at 2, that would be negative 4. And now we need to know the velocity of p at time 2. So you can either look at your sign line you had up here, or if you wanted to, you could just plug the number in. Either of those would be fine. I think when you plug it in, you get 3. But this tells you that it's moving to the right, but accelerating to the left, so it's slowing down. Or the speed is decreasing. That's how I'll say it, because that's how the question phrased it. And that's because the velocity and the acceleration have opposite signs. And now part D. Displacement told us is traveled using a schematic. Now a schematic is a drawing of the particle's motion, and we're doing this with P, so I'm going to draw a little schematic of x of P. And when you're drawing a schematic, you always want to know where it starts, where it turns around, where it finishes. So we would need to find the position at time 0, the position at the time where it turns around, which if you look at part A is at 1, and then the position when it ends, which is at 8. So we're using that for the position, which is this. So be ln of 10 for the first one, and then, and I'm going to do this on my calculator, so no big deal. Ln of 1 minus 2 plus 10, so that's ln of 9. And then 8 would be 64 minus 16, which is 48, plus 10. I'm going to check that, because, yep, ln 58. So now we'll get my calculator and get the decimal versions of those, which are these numbers. So to draw my schematic, I'm going to draw where the particle is at each of these times. So it starts at 2.303, and then it goes to 2.197, and then it ends up at 4.060. So if I want my displacement I could have found without drawing the schematic. It's literally ending position minus starting position, which is 1.757. And then my total distance traveled would be this distance, the positive version, because remember total distance traveled doesn't take into account direction, plus this distance traveled. So when I do that, I get 1.969. And since there were no units given in the problem, you don't have to put units on the answer.